Hi, welcome to Zona Mechanica. There is an MCQ on the power loss in a journal bearing. Figure at the margin indicates the weightage of the question, that is 2 marks. A lightly loaded full journal bearing has journal diameter of 50 mm, bush bore of 50.05 mm, bush length of 20 mm. If rotational speed of journal is 1200 rpm and average viscosity of liquid lubricant is 0.03 Pascal second, the power loss in watt will be. There are 4 options given. Well, so what are the data given? Journal diameter D is given as 50 mm. Okay, so bush bore diameter dj and db, bush bore diameter is 50.05 mm. So therefore the clearance C will be db minus dj, that is 50.05 minus 50 is 0.05 mm. Okay, and the length of the bush, okay, L is 20 mm. Okay, rotational speed, that is N, is equal to 1200 rpm. Okay, and the viscosity mu, okay, mu is 0.03 Pascal seconds. Therefore the velocity of the shaft will be V is equal to pi d, sorry, this d, pi d n by 60, since it is in rpm. Okay, so pi into d is 50 mm multiplied by 10 to the power minus 3. So pi into d into n, that is 1200 divided by 60. Okay, so which will give 3.14 meter per second. Okay, so this is the velocity. Therefore the shear stress tau will be mu into du dy, right? We know from the viscosity, right, Newton's law of viscosity. So mu is 0.03 multiplied by du. Du is nothing but this velocity. Okay, 3.14, sorry, 3.14 divided by dy. See, dy till, suppose this is the shaft and this is the clearance between the shaft and bush. This is the bush surface and this is the shaft surface. Okay, so clearly this is the clearance. Okay, clearance C, and here this is dy. Okay, so dy is equal to C is equal to clearance 0.05, okay, multiplied by 10 to the power minus 3. Okay, so this will give 1.885 multiplied by 10 to the power 3, okay, Newton per meter square. Okay, this is the shear stress. So therefore the shear force acting on the shaft F will be tau into contact area, right, contact area, this area. Okay, so pi d multiplied by L, right, this is the area, pi d multiplied by this L, okay, length, this is the area. So 1.885 multiplied by 10 to the 3 multiplied by pi into d into L. Okay, so 1.885 multiplied by 10 to the 3 multiplied by pi multiplied by 50 multiplied 10 to the power minus 3, since this is in mm and L is 20. Okay, multiplied by 10 to the power minus 3. Okay, so this will give 5.92 Newton. Okay, so this is the shear force. Okay, so we have to calculate the power loss. So we know the relation between the force, velocity and power, right? So the power loss will be given by this force multiplied by the velocity. Okay, so 5.92 multiplied by velocity is 3.14, sorry, 3.14. Okay, this much of watt, so that is 18.6 watt. Okay, see clearly our answer is nearest to option A. This is 37. Option A is the correct option. Okay, but you may say, why this much of difference? See, if we simply multiply this answer by 2, then it will match with this option. Okay, but that is meaningless, right? So as long as this is an MCQ type of question and the options are not closer to each other, so there is no problem. But if this is numerical answer type of question, then there will be a big problem. Your answer may not be right. Okay, because the range of the answer is given very closer to the right answer. Okay, the option A is the right answer. Okay,